being a bit late. Yeah, so. Well, nice to see you all here. So, you already have a morning of classes, so I hope you're enjoying yourselves, and I hope you enjoy yourselves even more now, right? So, what we're going to study on this course, right? So the idea is a bit different from the other classes in the sense that we will not talk so much about concepts, but the intention is to be a very hands-on course, a very practical course, and the idea is that you learn how to use the computer effectively to analyze models, to program models into the computer, to analyze them in several different ways, and for that we are going to use a specific language. You're going to learn specific techniques. There's a lot of stuff here that is generalizable in the sense that you could use more or less the same ideas and the same techniques in other languages, in other contexts, and with other types of models, with other libraries, and so on and so on. But the idea of this course is really that you not only learn the concepts, right, but also that you learn how to do it, right? So it gives you a lot of power. I think it's very nice to be able to take whatever problem you have at hand, whatever model, whatever idea you have, and you are quickly able to put it into the computer and see if it works, right? So it's a basic very basic principle that if you cannot even make it work in your ideas work in a very controlled setting, right? In a model, right? Then maybe your idea is not so nice, right? So if you're going to work in your projects, for instance, right? So in your projects, you're probably going to build models and so on, right? And sometimes it's hard to do all this stuff analytically, right? Only with pen and paper. But you can pretty much always implement it into the computer. Even very complicated models that you have no chance of working out by hand and so on analytically, you can always end up doing this for the computer, right? So I think this is an essential tool for any modeler, right? So yeah. So I wanted to not working. Maybe. Maybe plug it into your computer because this is not working at all. Because now I don't have the output to this, so I have to probably reboot it or something. Okay. Because I don't have any output. Right. So yeah. So let me try to reboot this. So. So what are now it would be a nice thing to have the stuff over there, right? So we are going to use Python, right? So this is a programming language that is it is very popular in the general programming setting, right? So it's used for web servers and I can even listen. Not even list all of the stuff that is used because it's one of the most popular languages around, right? So it's used for data science, for all kinds of tools in the web, all kinds of tools in other stuff, right? But it's also very popular in science computing, right? So I personally have used it for something like, I don't know, over 15 years now, right? So it's not an exactly new language, but it's been around for some time, so it's kind of very mature already. So it's not the new thing, but it's there are other languages, right? I think the statistical model course is going to be in R, right? But then I just tested this with Paulo, right? So we were thinking, oh, maybe we should. Given the same language, maybe I should use R for this, right? But then Python, there's a different philosophy, right? So there's in R, sometimes it's tempting to use packages for everything, right? I don't know how. Before I go into this, how many of you know how to program already in some computer language, any computer language? Almost most people. Okay. Okay. And how many of you have used Python before? Python. Python. Yeah? Okay. And R. How many of you have used R? Oh, okay, a lot more, right? So, yeah. So, the issue here, why am I not using R, right? R has a different philosophy where people like to reuse or use a lot of very specialized packages, right? So you see that you have a function and a package in there for pretty much everything you want to do, right? So, and Python doesn't have this same philosophy. The philosophy is a bit like you have a basic toolkit, and you have to build anything you want, you have to build from that toolkit, right? So you have to learn more in terms of programming, you have to have more skills in terms of programming in order to use these tools, okay? But then you become also, in my opinion at least, you become more free, right? Because you don't depend on anyone having built anything specific for that particular problem you have, right? So in R you can also do that, right? But then when you try to do something, you are tempted to just Google it, and then there will be a package that does exactly what you Google for, and then you're kind of discouraged to learn how to implement things yourself. You see what I mean? Yeah. Yeah. So we are going to do this in Python also because it's the language I'm most comfortable with. I also use R a lot, but we're going to use Python here, and is it working now?
It's the other computer.
Okay, so I had to log in here.
Go ahead.
Yeah. Ah, já tá. Oops. Can I?
Yeah. You need to leave, right?
Yeah. No. No, back. Here.
Yeah.
Yeah. Use another. Right. Here is.
Next.
Tudo bem? E agora? So, all of you are already in your computers, right? Yeah? If not, please turn on your computers now, right? So we are going to use it a bit, right? So, yeah. Isso.
Tem que fazer login também.
É, mas aí é automático, né? Ou não? Não, abre outra janela, eu acho que ele já pede se está logado. As telas são um pouquinho diferentes.
É muito ruim o mouse diferente, né?
Não sei mais usar notebook. Tá, não tá na minha conta, não.
Não tá na sua conta.
Mas não tá na mesma janela?
Então.
Abri o meu e-mail aqui.
Aí
tá
abre o seu e-mail, aí vem aqui. Aqui não tem o negócio do colar?
Aqui, talvez, não tem, eu acho. Não tem. Lodear no Olab mesmo. Tá vendo? Não tem. O jeito é lodear aqui. Ué.
Aqui.
Nossa.
É que quando você loga, supostamente ele vai pra tudo, né?
Mas...
espanhol esse computador. Fazer login. Aqui, ó. Aí vai aqui. Não dá pra ir aqui?
Não.
Next.
Não, mas...
Mas aqui a
Que
gente...
coisa
Aqui,
horrível.
ó. Troca aqui. Renato. Aí.
Ufa. Pronto. Eu vou achar que pro negócio é melhor... tem esse daqui. E tem um outro aqui. Dá pra abrir em outra janela? Pronto. E acho outra... claro, né?
Tá.
Acho que é melhor pra ver, né?
Isso.
Assim, acho que assim é melhor, né? Beleza.
Você quer o mouse?
Acho que vocês acham que eu ia querer uma cadeira.
Você vai sentar aqui.
Né? Tá bom. Beleza. Ok, so... mas falta projetar lá, né?
É aqui, ó. Você quer só projetar o laptop?
Exato. Tá aí, tá bom. Obrigado. Well, so, let me try to do this from... Oh! Tá mudado? Mas era virar pra frente, né?
Então senta de ladinho.
Ixi. Que, né? Well, it's long past the time when teachers just gave the back to the whole class, right? So all the time, right? So, well, so this is okay. So can you see it? Yeah. So let me send you the other one here, so you can already. Okay. Thank you.
No problem. Acho que aqui você consegue ver.
Okay, so let me share this with you. Where is it easier to share, or
You want to share with them?
yeah?
You need to open Google Drive.
Oh, there's the whole thing. Okay, so maybe I just shorten the URL and then they copy it. Yeah.
Yeah.
Yeah. Okay, so maybe you can just copy this link here. So maybe you, yeah. So this is easy to find, right? Yeah. So, did you copy it? Copy because I want you to go to the other screen. Okay. Yeah? What? Sorry? Okay? Yeah? Yeah. Python basics, yeah. Okay, so so this is more or less what I intend to go over this course, right? So we will start with Python fundamentals. I know that many of you haven't learned Python before. Some of you doesn't have a lot of experience programming, right? So, and I know that it's hard to, because this will be very fast, right? So Python Essentials will be very fast. I more or less today go over a lot of stuff about Python. And does it mean that starting today you are already an expert Python programmer? No, right? Of course not, right? You cannot learn how to program in a new language, even if you are already an expert programmer and so on. You don't learn how to program well in a new language over a couple days, right? So, but the idea is that you learn these basics, right? And you start to familiarize yourself with it, and then you will have a whole month to use this, right? And then the idea is that after the whole month, then this will be all very familiar to you, right? So don't worry about having to, keep all of it in your head right now, or you don't have to be anxious about it, right? You see what I mean? So we are not here to learn all of this in a single day, right? So we'll have a lot of chances to put this into practice and work with this and so on over the whole month, okay? So I know this will be, this is what I want to go over today, this Python fundamentals. Is more or less what you would learn over a kind of whole course on programming, right? So this is, we'll go a bit over like everything, but don't worry, okay? Don't worry, because the idea here is, this is also something that is, there's an interesting anecdote here that I have a friend, right? That when he was my classmate, right? And then when he started his scientific initiation, right? He learned to program in C, and then he went to work in programming with C++. That is pretty similar, right? But then he couldn't start working until he read a whole manual about everything about C++, right? So, and he took months to read the whole thing, So because it's really hard to know the whole thing. You don't do this, right? So we can use programming, we can program a lot of stuff, even if there are parts that we don't remember so well or we don't know very well yet, right? So this is okay, right? So the idea is that we can learn a few things, use it, and then learn a few more things and keep incorporating it, and then you see what I mean? So the idea is to keep growing our familiarity and expertise with programming. You don't have to know everything to start programming. You can build simple stuff and then later learn more sophisticated stuff and so on, okay? So the idea is just don't worry too much, okay? Then we'll essentially, for numerical computing, right? So for solving problems, mathematical problems with the computer, we'll have to use a few libraries. So what is a library? It's just a collection of functions, of objects, of types of objects, and this kind of stuff that makes it that adds functionality to the language, okay? And then these are the main languages that we are going to study, okay? This is NumPy for numerical Python. That is the language that contains the library that contains arrays that are the vectors, right? So we'll talk more about this later, not today probably. Then we have SymPy, that is for symbolic Python, that I decided to include because I think although this is not very usual for numerical computation, right? Because usually numerical means really numerical, use numbers, right? You don't want to treat analytical problems, right? Problems that you do by hand. But then SymPy is a way to treat analytical problems in a computational manner. So I think this would be very useful for you also in the other course, in the population biology course, because then you can use these tools to analyze models in an analytical way, to make a lot of calculations that are hard to do by hand. The computer can help you with that, right? So this is an addition. Then you have plotting, right, for plotting graphics. And you have SciPy, that is a really, really huge collection of libraries. It's a library of libraries, kind of, right? So this has a lot of tools about numerical programming, numerical computing, like numerical integration, rich finding, and especially of interest for us is what is called numerical integration, that is solving differential equations numerically, okay? So this will be our main focus, but maybe we have time to talk a bit about some other stuff quickly, okay? So these are the essential libraries, but then what are we trying to do with this, right? So the basic idea is is solving equations, okay? Mainly differential equations. I think we can talk a bit about difference equations also, right? So discrete time equations, recurrence equations, and then this is the interesting part, right? So the thing is, what do you do with a model? What can you do in the computer that is hard to do by hand? Or how do you thoroughly explore model equations when you don't know the solutions for them analytically, right? So how do you do that, right? So this is not a simple task actually, right? It's not simple at all. It looks simple, and it is simple when the equations are very simple, but you just discover in practice that few equations are actually very, very simple in the sense, okay? So even a couple or three equations can lead to a lot of issues numerically, a lot of different behavior, and if you don't have much of an idea of what to expect, only very thorough exploration of the model will lead you to find this stuff that you didn't expect, right? So it's okay. So yeah, so this is more or less, and in the end, I think in the final week, although most of the course we're going to look for small systems of equations, right? So this is mainly guided by what the population biology course does. Is usually systems of 3 at most 4 equations, right? Yeah. So most 4 equations, right? You can do pretty much all population biology with systems of at most 4 equations, 4 differential equations. But then I want to introduce a bit about large systems, right? So what I mean by large systems, systems that have a lot of variables, right? So for instance, if your population is distributed in space, right? Or if your population has a different structure like age or gene frequencies or stuff like that, right? So how do you code this kind of structure in a way that is not the dumbest way possible? That is like you writing you have 1,000 points in space, you program 1,000 lines of code, right? So, okay, you see? Okay, so this is something for next month, right? So, okay, so today let's go into this, right? So, do you have questions already? Yeah? There's one over there. Okay.
Can you return the short link, please?
Okay, sure. Here it is.
I have a question. I think it's a silly one, but what's the difference between a Python library and an R package?
Sorry? Can you?
What's the difference between a Python library and an R package?
Pretty much none. It's the same thing. Yeah. So it's just called different. I don't know. Yeah.
You shared with us the Python basics, and you were using the computational methods. And are we going to use this one?
Yeah, the laboratory. So I'm going to talk about this in a moment.
Thanks.
Yeah. No more? Okay, so yeah, let's talk about this first before going into Python. Okay, so in R, right, you have all been asked to install RStudio in your computers beforehand, okay? Right, so in Python, you can also install Python and these libraries into your computers, yes. Right, for that, if you want to do this in Windows or Mac, I really recommend that you use something called, let me write this here, it's called Anaconda. Okay. In Linux, you can do this the way you always do this in your Linux package manager. Just install the Python package, the Python NumPy package, Python SymPy package, and so there, each library has a package. and install that, right? But then, why I didn't ask you to do this beforehand? Because we won't need it in this hours, okay? We can do all of this in the cloud, okay? So we can just use Colab, that is a tool from Google that lives in the cloud here, that you can just run code directly from your browser, okay? So this is Colab, right? So Colab is a form of, is based on something called Jupyter or Jupyter. Some people call it Jupyter because there's a pi in the middle, right? So this is with an I. That is based on Jupyter Notebook, right? That is kind of like in RStudio where you can mix text with code, right? So you have cells like this one, right? Let me just do something here. Okay. So you can do this over here, like this is a text code, okay? And then you just do text, you see? You just text, and then it renders like this and so on, right? And you can render nice stuff like bold. You can use italics, you can use LaTeX if you like LaTeX, and so on. You can, you have other stuff here also. You can, in order to have this thing here in the left, you see this here. So you just use this these headings here, this hash. One hash is the first one. The second one is with 2 hashes, and with 2 hashes you have an indented hierarchy structure in your document. Yeah. So this is text, right? And then you have this other kind of cell that is code. Okay. So I want all of you to go here and just click play here. Okay. When you click play, it runs the code in the cell. Okay. So you can have your document interspersing code and text. Okay. Why is this nice? Because it makes it easier to do something that we don't do often enough. That is write code that is easy to understand. Okay. This is a nice thing of both Python and the collaboratory in the notebook format, that code is very readable, right? So it's a nice thing to do, to always explain what you're doing, why you're doing, when you're doing it, okay? So you see, instead of having just a lot of codes without explanation, you can easily put text in the middle and even rich text, right? With bold, with lists, with LaTeX, with whatever you want, and really build documents in this way, right? So I think RStudio has something similar, right? And with documents and so on, right? So this is more or less similar to that, okay? But this is kind of, you don't have to weave the document. You just go clicking cell by cell and it updates, okay? Okay, so I think there are already a few stuff here that I have. So let's just do something here that is, where is it? Yeah, it's in the edit here, or editar in Portuguese, and clean all, it's limpar a saída. So it kind of resets everything that you have done before, right? And the idea here is, okay, we are going, you see here in the index, right? In the menu in the left, right? So we're going to see more or less all the basics of the language: arithmetic, strings, booleans, comparisons, variables, lists, flux control, functions, and how to import libraries, okay? So it looks like a lot. So if you have done a programming course, it's more or less the whole programming course, okay? It's more or less everything it covers. If you have learned how to program before, right, then you more or less have to translate what you know about programming to do that in Python using what is here, okay? If you haven't much familiarity with programming, we will do it along the month. We have plenty of time to get familiar with this, okay? So let's dive in here, okay? So this is this is written more or less in a form of tutorial, okay? So, yeah. And now I don't have mouse anymore. É, tudo bem. Não, pode deixar. Yeah. So, yeah, this is really uncomfortable here. Ah. This is from my mic. Oh, yeah. Oh. Okay. Doesn't change much, right? So I think this is just for protection of it. Yeah. So this is written more or less in the form of a tutorial that you can read by yourself, okay? But then I think if I just told you, oh, just you read by yourselves, it would be kind of not very fun, right? So I will ask you to excuse me, right? But maybe this first and maybe the second class might be a bit boring because there's a lot to cover in the sense of having a lot of information, right? But then later on, I think this will be much more hands-on because we'll use a lot of class time. I know you have a full schedule already. Then I intend to use a lot of in-class time to work together. Okay? Okay. Okay. So let's do it, right? Okay. So. So I really encourage you to go and try to do this also in your computers, okay? And it's also nice to work together. So you have more or less natural groups of 3 here, right? So you just can talk around and see if everyone is doing the same thing as you're doing. Right now, maybe this is not necessary, but then when we have exercises, we can communicate more to get to this stuff, okay? So you can run this clicking play here. You can run this clicking shift enter, and then it runs, you see? And then here it printed the 2 here, okay? Arithmetic is really, really simple, right? You can just do the right? So this is not news to anyone, right? So this, is it easy to read in the screen over here? Yeah, so that it in point, yeah. Okay, so this is all pretty basic stuff, okay? This is very simple. One tricky thing is that division of integers results in a floating point. Everyone knows what a floating point is? The difference between an integer in the computer and a floating point. Okay, so a floating point, it is not an exact number, pretty much never is, okay, unless this is a power 2. But pretty much any floating point is inside the computer is an approximation, even for an integer, even like 7. Well, 7 might be exact, might not. Yeah. Even round numbers, right? Even round numbers, you think, oh, this is a round number. It's probably represented exactly, but this is usually not the case, okay? Inside the computer, even nice round numbers sometimes are represented pretty much like this thing here, right? Pretty much like this. You know, this is not exact. It means it misses a lot of trees over here, right? So of course this is not exact. This is an infinite decimal, right? But then even numbers like 7.0 can be represented by something that is not exactly 7.0 internally, because the computer does this with powers of 2, not powers of 10, okay? Okay, so this is a good thing to know. And then if you actually do need integer division, right? If you want to divide, I don't know, 45 by 5 and get 7 an integer, then you have to use this double slash, okay? Double slash does integer division, and then it returns an integer, right? So it doesn't it ignores the rest, okay? So for instance, let me copy one of these here, right? So this is 5 divided by 3, and this is over here, yeah. So this is 1, okay? 5 by 3 in integers is 1, okay? And this is in the same for negative numbers, and you can even do integer division with floating points, right? If you do this here, it will work. It will treat both numbers as integers, and we'll give you the integer division, right? Okay. A bit more about arithmetic. We have the modulo operation. I don't know if you have ever seen this in your life before. That is the rest of division, right? So this is it here. So 7 divided by 3 is 2, but the rest is 1, and then this operation gives you the rest. You have power. In many languages, power uses this character, this circumflex symbol here. It's not so in Python. Python uses this symbol for other stuff that we don't need to talk about. And in Python, you use 2 asterisks, okay, for powers. Okay, so this is like this, right? So, yeah. Like this, you see? Okay, and then the other basic stuff is that you can always use parentheses to change the order of the operations. Okay, this is more or less obvious. Okay, okay, so far, yeah. So this is starting slow. Okay, right? Yeah, everyone is comfortable. Yeah. Okay, starting slow. Okay, now let's do strings. Right? What is our strings? Are just text. Okay, text. Strings in many languages are seen as lists of characters. This is also the case in Python. Okay, so you can always view a string as just a list of characters, okay? And for instance, let me run this thing here. So this is a string. You delimit a string with quotes, okay? Either double quotes or single quotes, doesn't matter, okay? And you can concatenate strings together by summing them. If you sum this hello with this word, you get hello word. If you And as I said, since a string can be treated as a list of characters, you can take the letters from the string using this notation here. So what is this? This is the string hello world, and then I take the first element from this string, that is the H here, you see? So this is a bit more fun, right? Yeah? Okay, and I do this directly, you know, I don't have to pass this to a variable and then call this thing here, okay? So in Python, this is something that if you learn it R, this will be a bit confusing, because in R indexes, the first element is the 1 index, okay, the index 1, so it take a list 1 is the first element. In Python, as in C for instance, the first element of a list or sequence in general is 0, okay, the index 0, so it starts counting at 0 and not at 1, okay? And then you have this function len here, that is the size of the string, how many characters are in the string, okay? If you have questions, just raise your hand, okay? So I don't stop every block, okay? Okay, so, and some nice thing that you can do also with strings is that you can include variables inside the strings, okay? So you have these braces that you include inside the strings. When you use this delimiter, just before the delimiter, if you include this f here, this f of format, if you want to format this string with variables inside, you open it with f, then the quote you want, either single or double quotes, and then you can use variables inside. You just put the variable in braces here, and you see I define a name. In Python, assignment is using the equal sign, okay? And then I defined this variable called name with the string quantitative ECOLOGY, and then I included this inside this other string here. And when I print this, what happens is, welcome to the, then it substitutes the content of this variable here and puts inside here, you see? Okay? So this is very, very useful, okay? Very, very useful. Another nice thing is that you can not only do this, but you can also include expressions inside this braces, okay? So I have here, it's not just a variable, it's a function applied to a variable, you see? So you have here the function that counts the length of the string, and then it tells me that this string has, you see, this string has, this number has 20 characters. Yeah, simple. Okay. And then you see here that there's a quote, here a single quote. If I want to use a single quote here, I put the single quote inside a double quote. And this is okay, because the delimiter now is the double quote, and the single quote is just a regular character. If I want to include a double quote inside a double quote, then I have to escape this with these backslashes here, okay? So you have the double quote in here, double quote here, and these two double quotes that are escaped, they don't finish the string, see? So this is also something useful to know, okay? Yeah. Something that I didn't comment is the comments, okay? Inside the code. If you want to write stuff in the code that is a comment, you just begin with these hashes here, right? You can do this either in the beginning or the middle of the line or after something, right? So I think there's some examples here, okay? So you have this here, this is not executed, right? This is not run, okay? You can do this, and everything from the hash forwarding that line is a comment, okay? It's not run. Okay, now Boolean variables. We have three, and, or, and not, okay? And this is called and, or, and not, okay? You can also do this with those commercial E's and the vertical bars and so on, but it's, in Python, it's common practice to just write this down, right? To write this as and, or, and not use the vertical bars and so on. You must pretty much never see those, okay? Okay. And then you have this stuff here, right? So this is pretty much straightforward. You have true and false as false, true or false as true, not false as true. This one is a bit more complicated. I don't know if you want to try to predict what this is going to be. True or false? Votes for true. Votes for true. Votes for false. Well, you print something, right? And now it's just guess. True or false? Come on. So how do you evaluate this? Well, let's think together. Okay, how do you evaluate this? You don't see any parentheses. Okay, you don't see any parentheses. And and or have the same hierarchy, right? So you start left to right. Okay, so you start from the left. This is true and false. Well, with and, both have to be true for this to be true. So this true and false is false, okay? So all of this here becomes false, okay? But now you have false or true. Just one of them needs to be true. The second one is true, so this is true. Okay? Yeah. So, yeah, so this is, yeah, okay. Right? Nice. Okay, and of course, in convert numbers and strings to booleans, to true or false. Be careful with true and false that in Python, you always have to write this exactly in this way with the capitalization. You cannot abbreviate with only T and F, right? So this is always the way it is. You can convert this numbers that are non-zero are true, 0 is false. Empty strings are false, non-empty strings are true. This is not very useful at all, but it's here for, I don't know why. Yeah. And you have now comparisons, equality, inequalities, and so on, right? So equality is with two equals, like in most languages. Inequality with exclamation point and equal, greater, greater or equal, less than equal. So this is all very, very straightforward, okay? So we just, yeah. Yeah, so this is simple. So you see, it's enough long, but it's all very simple so far. And we can combine these. Now, if you have this comparison, then you have and or that we saw over here, right? And for instance, if you want to check if a number is in an interval, okay, between 1 and 3, okay, you just check that it's between, that the 2 is larger than 1 and smaller than 3, okay? You just combine this and this part here, okay? And this is useful to know that and or, the Boolean operators are usually the last to be evaluated, so you don't need so many parentheses, okay? So you don't need parentheses, you don't have to worry that 2 and 2 will be evaluated before the 1, less than 2, okay? So this will be evaluated first, and then this one, and then the end, okay? The end is the last one to be evaluated, okay? So you don't need so many parameters. You don't need to do this, right? So you don't need to go and write something like this, right? This is unneeded and leaves the code less readable, okay? So the idea is that the code should be more or less readable, okay? And you see here that 2 is between 1 and 3, and 4 of course not, right? Because this one here is false, okay? So yeah, of course. Now let's talk a bit about variables, okay? So variables, we are kind of already used it, right? But then you always have this assignment with equal. You don't have this arrows as in air, right? You don't have that at all. That just doesn't exist. And here we have a simple example. Yeah, I forgot to translate this. Funny. Well, but one convention about variable names, of course you can use any variable name you want, right? If you just want to start with A, B, C, D, E, for all your variables, you can of course do that, right? But this is usually helpful to give explanatory names to your variables, right? So you don't get confused in the code, okay? And usually we use variable names all lowercase and separated with this underscore over here, okay? You cannot use dots, okay? In R you use a lot of variable names with dots, but we cannot do this in Python because dots have a purpose in terms of syntax that we will see later, right? So we use dots to get objects inside other objects or methods in classes and so on. So you cannot use dots inside names of variables, okay? This will give you an error, okay? So this is, and you can read input from the user using this function called input, okay? It prints this thing here and expects that you print something, that you write something here, okay? So this is something here, enter, and it printed what I just included here, see? Yeah, this is, yeah. This is usually not very useful unless you're doing programming 101, okay? You never ask the user for anything usually, but okay. Okay, and now something that is very useful to know is that how it show. You see that here it's already something red here, right? What is this red thing doing over here, right? It already knows there's something wrong with this, right? So I try to run this, and it gives me an error, okay? Because the variable a was not defined before, right? And you see that it does a lot of stuff here. It tells you in which line it is. It highlights the point where it happened, the error, and it tells you something about the error. There's the type of the error. This is the name error, right? Of course, this is very obvious in this code that has a single line, okay? There's no doubt where the error is, what did you wrong here. But when you have a large section of code, okay, it's very useful to get to see where the error is and what is the error, okay? So name error means usually that you don't have that variable defined, okay? So this is useful to know, right? So there are other kinds of errors that we'll see that will help you to debug, okay? So when you program, okay, you think, oh, okay, most of the time you spent programming is not spent writing your code, okay? Most of the time you spent programming is spent fixing your code, the errors that your code had to begin with, okay? This is, debugging takes much more time than writing code, okay? This is why it's useful to know the tricks of debugging, you know, okay? So this is also something that I want to work a bit during the course, okay? Doing some debugging, some practical, some practical debugging skills, okay? Yeah.
There's a way to run the code line by line? Because
well, usually if you want to do this, it's better to just break into separate cell codes, okay? So for instance, suppose that the next step here, right? I want to run this line and then separate over here, okay? So you can just, I think there's edit, good, where is it? I think it's over here. Over here. There was a function somewhere. I think there's a shortcut. Let me see if it works. Yeah, there's a shortcut to. What did I do here? Yeah, there's a shortcut, but there's no. Ah, thank you, thank you. Yeah, insert. Yeah. Yeah.
Não, runtime, ambiente de execução.
Sorry?
Ambiente de execução. À direita, aí. Executar a seleção. Seleciono.
Ah, okay. Yeah. Okay, you're right. Okay. Yeah, if you want to yeah, so maybe what I did was not so nice, because if you want to really have separate pieces of code that you always want to run more or less separately, then it's better to really separate into different cell blocks. For what you want is what he just said. You just you select the piece and then and you go execute selection, executar seleção, right? I think it's yeah, you can also use this with Control Shift Enter. Yeah, Control Shift Enter. Okay, so this is not exactly line by line, but it's close. Okay, right? Okay. Good. So, okay. So lists. Okay. So lists are the simplest kind of collection of sequences. Okay. And the thing with a list, for those that know R, lists are similar to lists in R, not with vectors. Okay. So lists can mix different kinds of objects, so you can have a list that contains a number and then a string and then another list and anything, right? So you don't have to all of the elements be the same type. Okay, so this makes it useful for some things, but very inconvenient for others. Okay, so this is why we will learn arrays later. Okay, but for now, let's see what lists look like, right? So we always use brackets for defining lists. Okay, so this is an empty list, for instance. So let me run this here. So this is an empty list that is represented like this, right? So when you print it, it just appears in this way. And then you can create a list like this, just including the elements inside. And when you print it, it appears like this. And you can also take this empty list and append elements one by one. Okay, so you append 1, you append 2, you append 4, you append 3, and you keep growing the list. So you can just append it item by item, element by element. You see? Okay. Here there's something that it's already a little bit different from other stuff, right? You see that what this append thing is doing? So you have li here is a list, okay, is an object. To append stuff to this list, you call li.append. You see, so append is a method of lists. You see? So you use a dot to call a method of that kind of object. You see? So you call li.append, dot append, 1, 2, 4, and so on, to add elements to that list. Okay? Is this clear, or is this confusing? So append in some sense is a kind of a function, but it's a function that is applied to this list. You see? Okay? Yeah. Okay. And there's another one here that is pop, that is that it removes the last element of the list. You see? So when you pop the last element, when you li.pop here, now the list doesn't have the last element. Okay? And you can again use this function len here to know the size of the list, the number of elements. Yes?
Just to be sure that I'm understanding it clearly. So you said that li.append is it's like a function. So if my object was named anything other than Lee, I would have to use the name of the object before
Yeah,
dot
so if I want
append.
to change otherly here, okay, otherly here is 456, right? So I can just do other, oops. What did I do here? Oof. Here. Otherly, oops, where is the otherly here? Dot append, some no, oof. Then over here, and now I will print this stuff. Okay. You see? Now there's a 10 over there. Okay? Yeah.
Can you only append other objects, or can you append a list?
You can
to
also
another?
it can append anything, right? So you can also append the Lee here. Yeah? You see what's going to happen here? Okay? Anything. Okay? A list is very, yeah?
Oh, so there's a list inside the list.
Yeah, exactly. And you have lists inside of lists inside of lists.
Okay.
You can have,
But if I wanted to
anything.
append the elements inside of Lee to other Lee.
okay, so we'll see this now.
Okay.
Okay.
Thank you.
Okay, so if you want to get an element from inside a list, this is what you're asking, right? You have to index it, okay? So a list has elements, and you have, this is the first, the second, the third, the fourth. The fourth element of this list here is the list 1 to 4, okay? This is the fourth element, okay? And then you have to get this element, and then with this element, get the element inside. So you have to index it twice. This is the question, right? So how do you do indexes, right? So you again use brackets, okay? Use brackets with the index inside, okay? So Lee bracket 0 is the first element of the list. Lee bracket 1 is the second, and so on, okay? Yeah.
Mas para juntar duas listas só usar o mais?
Sorry?
Para juntar duas listas só precisa usar o mais?
Yes. Yes, I'll talk about this very soon. Yeah. So one different thing that Python has, especially compared to R, is that you can use negative indexes. When you do this, when you do Lee minus bracket minus 1 in R, what does this do? It removes one element from the list, okay? In Python, this is completely different. What this does is that it starts counting from the end of the list, right? So Lee bracket minus 1 is the last element of the list. You see? Minus 2 is the next to last. Minus 3 is the third from the end, and so on and so on. Okay? So this is actually very useful in a lot of contexts, right? So this is would give you an error in the middle, okay? But this part here, this is the first element of the list. Let me print the list, the original list here, because I forgot already. Yeah. So this is here is, oh, the list is only 1 and 2, yeah. And okay, let me run this here again, because I ran twice and then it reduced the list. Yeah. So the list was 1 to 4, and now the first element is 1, right? So this is Lee bracket 0. The last element is Lee minus 1. So this is the 4 here, okay? Right? And then you can use, if you want to delete some elements from the list, you have this keyword called del, okay? And then this is how you delete elements from the list. You use del and the index of the element you want to delete, okay? When you do this, right, what happens? The list is now shorter, okay? You deleted the 4, right? Because I deleted Lee 2 here, okay? Is that clear? Yeah? No? So what, let me, the problem is that I have to redefine this, otherwise, yeah, let me just write this over here. Let's see. What was it? Yeah, 1, 2, 4. Yeah. So here it is, right? So here I deleted lead 2, right? Here. Del lead 2. You see? When I delete, if I del lead 2, then I deleted lead 2. What is lead 2? Let me run this again, printing this one. Lead 2 is the 4, okay? So I deleted the 4, right? If I instead had deleted lead 1, I would delete the second element, okay? Oops. Oh. This keyboard is really confusing me. Yeah. It is. Yeah, now it's giving another error, okay? But don't worry. So you see, now I deleted lead 1. That is, I deleted the 2. Is that clear now? Yeah? Yeah? I can hear you, sorry. Yeah, but I think it's okay. I think it's solved. Yeah. Okay, so another error that is very useful to know, right, is what happens when you try to get an element of the list beyond the number of elements, right? So if I try to get Lee index 4 here, okay, what finds is that you have an index error, okay, because you see the index is out of range, okay. This is also another very common error, and it's nice to recognize when this happens, okay. Okay, so let me go back again. Now another use of del is that you can remove a variable, okay. So here you have x equal to 1. I print x here. I can delete the variable x, and now it doesn't exist anymore, okay. So this is why there's this error over here, okay. Here I printed 1 here, and now when I try to print it again, this variable doesn't exist anymore, okay. So this is also another use of del. It deletes elements of the list. It also can delete variables from your environment, okay. Clear? Okay. So moving on, let me here redefine Lee. And now another way to remove elements from a list, you can search for elements and remove elements from the list, right? So for instance, here you have a 2 here, okay? If I call this other method called remove, I remove the first appearance of the 2 here, right? So for instance here, right? So oops. Yeah, this I should have breaked this more so I don't have to. Yeah. So what happens? I remove a 2, right? And then you have 1, 4, 3. You see? 1, 4, 3. If I try to remove again, right? If I try to remove an element that is not in the list, then it gives me an error, okay? It's a value error. Because this element is not in the list. You see? So one nice thing about Python is that the errors are very readable, okay? If you just read what is written here, it tells you X not in list, okay? So this is more or less obvious what is going on, okay? Yes?
If the number 2 appeared more times in the list.
Nice question. So if it appears more time, it will remove only the first time, okay?
Okay.
So you see, here I remove it the first one, but not the second one. Then when I call it again, then it will remove the second one, okay? It removes the first appearance only, okay? Okay. And insert is similar, but the opposite, you can insert an element, because you remember that append always grows the list at the end, right? If you want to insert an element in the middle, you have this function called, this method called insert, that inserts at the given index this value here, okay? So if you want to insert at the second position, remember 0 is the first position, 1 is the second, and so on. So if you want to insert a 1 in the second position, you do this in this way here, and now you get a list with 10 in the second position, you see? Okay? Okay. Finally, if you want to put two lists together, okay, there are two. I think I went over this with me. No, it doesn't. I didn't show this here. Yeah. So if you want to put two lists together, right? You can just sum them together, okay? If you just sum two lists, what does it mean summing two lists? It's just concatenating them, right? Making a single list with all the elements of the first and then all of the elements of the second, okay? So if I have here Li and other Li here, this is, let me run this again. Yeah, but now I removed the all the choose here, okay? So this is not, let me just, there's this other, I have to go back and remove this thing here. Yeah. Okay, now it works. So there's this index here. Oh. Yeah, you see how debugging is most of the issue, right? Always. Oh, well, yeah, but then, I wanted to comment something I used on that and not on hash. Okay. Yeah. Debugging again. Yeah. But, okay, this is an expected bug, I think. Yeah. So, or not. Yeah, so this is expected, right? So you can use this function called index that searches for the element in the list and gives you the index where it appears. You see? So if you have this list here, let me print it here, okay? I should maybe have broken this into more steps. So you have this list here. You are looking for the 2, right? Where the 2 appears is the 50 element that has the index 4, okay? So this is what index is for, right? And if you try to look for an element, for instance 5, that is not in the list, it gives you this error here, right? Once again, it's a value error, okay? Now, of course, to keep going here, I'll just comment this line so that it doesn't give you an error. And I put in a arroba then, okay, over, okay. This is an index, and now the sum of lists, okay? So this is Li plus other Li. You have this whole stuff here, right? So this is first the Li part is here. This is the other Li part. You see that summing them doesn't change them, okay? It creates a new list, okay? That is the sum, okay? If you want to take one of them and put the second inside the first, you have this method called extend, okay? So this is, extend. So this is extend the list Li, including the elements from other Li, okay? Yeah, okay. And finally, I think this is probably the most useful thing here, is that you can check if an element is inside a list using this operator called in, okay? This is pretty much like in R also, that you can, returns a boolean. Is the element inside this list or not, okay? Yes.
What's the difference between the extend method and the append method?
The append adds an element. The extend adds, the extend receives a list. The append receives an object. You see, so let me do something.
So
something
extend only works for
so
lists?
let me do, let's try this. Oh, once again. So let's try this. So let me 1, 2, 3, and B is 4, 5, 6. Okay, and if I do a point extend, a point extend B, and I print A now. Okay, what happens is that I have a list with everything, okay? If I do A instead of this, I do A point append B. You see the difference? Now the whole list is a single element. You see? And what if I try to just use extend with something that is not a list? This is an error. Okay? You cannot extend a list with something that is not another list. You see?
And then what's the difference between extend and just
Plus?
yes?
Yeah, this is what I explained in here, because this
the
here,
type of object.
with this here, okay, with this here,
Okay.
you have the A list is now this whole thing here, okay? If I just do A plus B, and let me omit this, right? Of course. If I do just this, I don't change the list A. You see? I could have also, well, another way to do extend is do this, right? A equals A plus B. This is pretty much the same as extend, yeah. Of course, internally it's not exactly the same, because you create a new list and then you assign this new list to the same name. And A point extend is somehow a little bit more efficient in terms of taking the same list and increasing the memory. You see, it doesn't create a new object. You see, it's a little bit different, but the result's the same. Yeah. Okay. So yeah. So in is pretty much like in R, and now you have this thing here that is pretty funny. Okay. You can take a list of variables and attribute it to a list, and assign several variables at the same time to a list. And this means that X will take the value 1, Y will take the value 5, and Z will take the value 10, okay? So this is what I illustrate here, right? So this is when I print this stuff here, okay? This is, you have to be careful, don't use this. You can use this very badly, right? So if you have a lot of, I don't know, if you're defining parameters, defining a lot of variables, don't use this to save space, okay? Use this only when it makes sense, when you have naturally a sequence. For instance, in this case, you are thinking of X, Y, Z as 3 ordinates. So it's you know, these 3 values together make sense. So it makes sense to do this here because this is a vector composed of X, Y, Z, okay? You're not trying to save space. These 3 things together make sense, okay? Then this is a nice thing to do, okay? Okay, and finally, still about lists, you have slices, okay? Slices will be very, very useful for us, especially in terms of arrays later. And the thing, yeah, oh, we are already close to finishing the time, okay. The thing with slices is, here I did something funny. What do you think this does? 2 times the list 1 to 4. Multiply, you think this will be a list with 2, 4, 8?
No, I think it would be a 6.
You see, lists may not contain numbers. What is 2 times a string, or 2 times a function, 2 times an object, any object? You see, it doesn't make sense. So when you're talking about lists, 2 times a list is the list duplicated. So it's this thing here. You see? Because it makes sense for anything, right? But for numbers, when you want to work with numbers and you want to multiply each number, then you use not a list, you use an array that we'll see later, okay? Okay, and then what does slicing do? I just did this to be funny, right? But what do you do when you want not the whole list and not a single element, but a few elements inside a list? Or you want kind of a sublist, a list that is a piece, a part of the whole list. You do what is called a slice, okay? A slice is something like this. Instead of having a single index, you have one index that is the first element that you're going to take, 2 dots here, and the last element, okay? One thing to be careful is that the last element is not included, okay? So this 1, 2 dots here, 3, we'll take this list here. The first element is the second, right, 1. the index 1 is the element 2, and the last element will be the index 3, right? So 0, 1, 2, 3, the 1, but the 1 doesn't enter, so you only have 2 and 4. Okay? So this is a very common pattern in Python, where you have, you always, when you have a slice, you have the first element, you include the index of the last one, but you exclude the last one. Okay? So you can omit either one of them. So if I want all of the elements until the end, I just put the 2 points here, 2 dots here, without anything after. So it goes from 2, right, from the third element up until the end of the list, right? And if I omit the first one, I take all elements from the beginning until the third one. Okay? So like this. So you see here I cut two elements here. I cut the 1 and the 2 started in the 4, and here I stop it at the third, right? So I just got 3 elements here, 0, 1, and 2, right? I don't have the elements of index 3, okay? And finally, one thing that is also very useful is that you can use negative indexes also here, okay? So if I want the last 2 elements, I start with the -2, okay? And if I want every element except the last 2, I end at the, oh, those are 2, yeah, this is wrong here, this is like this, right? So, yeah, like this, you see? So here I got only the last 2 elements, -2 forward, and here I got all the elements from the beginning, except the last 2 ones, that is the 2 and 4 here, okay? Is that clear? Yes? This is a bit confusing in the beginning, but once you get the hang of it, this is really, really nice, really useful. Slicing with negative numbers and so on, okay? Yeah. And this is also interesting. It can also take a third value, that is a step. You can take elements, here I took just the naturals here. You can take them 2 by 2, right? With if I put a third thing here, 2 dots, 2, I take the even ones, 0 to 4. If I started at 1, I will start with 1 and do steps of 2, right? So I take 1, 3, and then 5 is already beyond the 5 here, right? So I don't include 5. Okay, so you have, again, the same thing. You have start, last element, but then you also have step, and also have negative steps. So you can, negative step means that you are going backwards. You start from the end of the list, you see? So it's a way to reverse a list, for example, is just doing this, 2 points. I start from the beginning, I end at the end, I count I count backwards. So I have the same list backwards over here. You see? And I can have the list backwards, but only 2 by 2. So it starts with 6, then 4, 2, 0. Okay? So there's a lot of stuff that you can do with this. Okay? Okay, so it's almost 3:30, I think. Yeah, I think I'm going to stop this for now, right? There's something else I want to show, but we'll go over the rest of this tomorrow, okay? But there's something that I want to pay attention to, right? That is the following, right? So I share this with you with this URL here, okay? Right? So this notebook here, okay, this is, I created it, okay? I can just go over here, Archivo, new notebook, and so on, and you have a new notebook all for yourself. When you share this, okay, when you share this, you have several options, okay? If I share like I did this, right? So any person with the link can read this, okay? The notebooks that you're editing on your computers right now are copies of mine, right? So you can add on your own over there, and it will change a copy that you have for yourself, okay? So you don't have to worry about doing some stuff over there that I will not see what you're doing, okay? So this is what I would do with all the material of all the classes. Okay, I will always share it in a way that you only have read access, and when you start playing with it, to only change your personal OP, and you already have an OP. Okay, if you are, I recommend that everyone works with this loaded onto your Google account so that it saves all of your notebooks in your Google Drive, your personal Google Drive. But something that you can also do, right? You can also add people. I won't do this here right now, as editors, right? When you add people, usually instead of doing this with the link, you add people over here, okay? But if you add people as editors, then the people can edit the exact same notebook you have, right? And this is a bit dangerous because it doesn't support very well two people editing at the same time. So don't do that, right? So because it's a mess, okay? It's completely messed up. Don't do this because it's going to produce some monster mixing the edits of the two different persons, and it doesn't work very well, okay? So usually you can edit in the same notebook only if you are not working at the same time. If you're working at the same time, it's better to create copies, and then someone works on a piece, and then this is incorporated in another into another OP, you see, so that you don't end up with something that doesn't run at all, okay? Good. Okay, something else that I know it's already over. No, we talked about this last class, right? So we have a lot of classes. So let me stop here. Do you have any more questions? Any more comments? Any more? As I told you, I already apologize, right? So this first few classes will be kind of boring. Okay, sorry, it will be kind of boring. I know it's kind of boring to just go and scroll down and show you stuff. I think if you read this also at home and so on, it helps you familiarize yourself quicker. But most of the course, I promise, will be very hands-on. Okay, sure, yeah. Okay, so bear with me for a few days, and then we'll, yeah. Okay. So questions, comments? Okay. So see you tomorrow. Beleza.
Oi, pessoal, fica aí que eu já vou ir com mais recados.